Jai Hind everyone. In this lecture of the subject Energy Science and Engineering KOE 033, I am going to discuss about the hydroelectric and tidal power plants. Starting with the hydroelectric power plant. In hydroelectric power plants, the energy of water is utilized for generation of power using the kinetic energy and potential energy of the water which is in motion and holding a certain position or head. Hydropower is considered as one of the most economic and non-polluting sources of energy. The power generated from water is said to be the hydroelectricity. In fact, tidal power is also a form of the water power, but the system is different. Hydroelectricity means electricity which is generated by hydropower or from the use of the gravitational force of falling or of the flowing water. The potential and kinetic energy are the two energies which are involved while converting the hydropower to the electrical power. The potential energy is the stored energy in an object or system because of its position or the configuration. So, water is stored to certain level to increase the potential energy of the water. Then this potential energy is utilized to run the turbines. Directly that potential energy cannot definitely run the turbine. So, potential energy of the water gets converted to the kinetic energy of flowing water while rotating the shaft of the turbine. The kinetic energy of an object is relative to other moving and stationary objects in its immediate environment. So, potential and kinetic energies are utilized for conversion of hydropower to the electrical power. A number of energy conversion will take place, number of energy conversion processes are there while converting the hydropower to electric power. A schematic representation of the hydropower is shown over here. It utilizes the water mass that flow due to gravity to turn the turbine and thus turns the coupled generators. The generated electricity from generator passes through a step-up transformer and then it is transmitted to the load in distance. It is transmitted to the load center. The schematic representation of the hydroelectric power plant can be seen over here. Starting from here, it is the dam which is used for water storage. Dam actually controls the amount of water as well as the head. We can very well see the dam over here. This is the stored water. Then intake gate where water flows into the penstock. At this point, we can see the intake gate. It is a valve through which the water flows into the penstock. This is the penstock. Penstocks actually carry the water to the turbines. We can very well see the presence of turbine over here. The inlet valve opens to let the water flow into the turbine. Another inlet valve is present over here. This inlet valve is responsible to let the power flow, to control the power flow into the turbine. Then water force acting on blades and turns the turbine. We can very well see the turbine over here. This is the reason holding the turbine. The water power gets converted to the mechanical rotation of the turbine. This mechanical rotation of the turbine is given to the coupled generator. So, generator getting mechanical input gives the electrical output. That electrical output can be seen over here. As I mentioned, it goes to a step-up transformer, then to the transmission line. The water outlet from turbine goes to the river. This diagram is representing various energy conversions taking place in the hydroelectric power plant, right? So, starting from here, it is the dam. Dam is holding the water. Because of this head, there is potential energy containment of the water. This potential energy gets converted to the kinetic energy. This kinetic energy of flowing water actually gets converted to mechanical energy by the turbine. The turbine is coupled with the generator. The output of the generator is electrical energy. Generators, all these electrical generators or alternators actually work upon the principle of electromagnetic induction. And in between the two parts of the generator, which are the stator and the rotor, the transfer of energy is actually through magnetic circuit. So magnetic energy is also involved in this conversion. So various forms of energies which can be seen here are the potential energy of the water which is there in reservoir, water stored in dam, then kinetic energy of the flowing water, then mechanical energy obtained from the turbine, then the electrical energy output of the generator, and inside the generator, because of electromagnetic induction, the magnetic energy is also involved. Let us see various advantages of hydroelectric power plants. They are very efficient as compared to their counterparts, which are the thermal power plant. Thermal power plants operate at a conversion efficiency of roughly 35% to 40%, but not beyond 40%. Hydroelectric power plants are very efficient. They are actually the most efficient method of power generation with an efficiency of more than 80%. Fast startup in matter of minutes, which is suitable during the peak load supply. Clean renewable energy, we know that there is no direct waste and carbon emission during power generation with the help of the hydroelectric power plants. Along with these advantages, there are certain disadvantages too. Let us see what are the various disadvantages. Huge amount of civil works are required to build dam and the powerhouse. So the initial investment of hydroelectric power plants is very high. Unpredicted power output in several places due to weather and the season. It is dependent, water power is dependent upon the rains. So if we do not have sufficient storage, if the storage is dependent upon the rain, then we may not have sufficient amount of water throughout the year for a constant level of generation. Turbines are life-threatening for fishes. We do have solution for the same, but again, it will require certain arrangements and initial investments. So, solutions are the fish leading system, fish ladders, and the fish passage system provided to save the life of the fishes. The flow sheet of hydroelectric power plant, it is representing the various parts of the hydroelectric power plant, like the reservoir, the catchment area, the dam itself, sluice gate or the valve, the penstock, the inlet valve, the turbine, tail race, the draft tube, and the three-phase output through the generator or the alternator. Starting with the catchment area. The catchment area of a hydro plant is the whole area behind the dam, draining into a stream or river across which actually the dam has been built at a suitable place. So that entire area behind the dam is said to be the catchment area. You can very well see the catchment area over here. The reservoir, whole of the water available from the catchment area is collected in a reservoir behind the dam. The purpose of storing water in the reservoir is to get a uniform power output throughout the year. A reservoir can either be a natural one or the artificial one. A natural reservoir is a lake at high mountains, and an artificial reservoir is made by constructing a dam across the river. Let us see what the dam is. A dam is built across a river for two functions: to impound the river water for storage and to create the head of water. It is the head of water which decides the capacity of the dam in terms of the electrical power that can be generated out of the water stored in a particular dam. Dams may be classified according to their structural materials, such as it may be timber or steel for very small head dams, earth, rock filling, etc. Spillways. When the water enters the reservoir basin, the level of water rises. To relieve the excess amount of water, a structure is provided in the body of the dam itself, or near the dam, or on the periphery of the dam. The purpose is to release excess amount of water to protect the dam wall, to protect the dam structure from the forces that will be exerted over it because of excess amount of water. The safeguarding structure, this safeguarding structure which is used for the safeguarding of the dam is said to be the spillways. The conduits. A head race is a channel which leads water into the turbine, and a tail race is a channel which conducts water from the wheels. So, head race is towards the input side of the turbine and tail race is towards the output side of the turbine. They are through the conduits. The conduits may be the open one or the closed one. Open conduits are actually the canals, and the closed conduits are usually the pipelines or the tunnels. Then comes the surge tank. You can see the presence of surge tank over here. This is reservoir, this is dam, this is penstock, and over the penstock we have got this surge tank. This side we have got the turbine, this is the tail race, the output of the output side of the turbine. So, what are the surge tanks? They are small reservoir or tank in which the water level rises or falls to reduce the pressure swings in the penstock. Prime movers. The prime mover converts the energy of water into the mechanical energy and further into the electrical energy. They are classified into impulse turbines and the reaction turbines. The prime movers are said to be the prime movers because they are used as something which is providing the mechanical input to the generator, which is providing the mechanical input to generator, and generator is responsible to provide the electrical output. Draft tubes. The draft tube serves two purposes. It allows the turbine to be set above tail water level without any loss of the head, and it regains by diffuser action the majority of kinetic energy which is delivered to it from the runner. The powerhouse. The powerhouse is a building in which the turbines, alternators and the auxiliary equipments and plants are placed. Now, after this, let us come to the tidal power plants. Let us see an introduction of the tidal power plants. As I told you earlier, tidal energy is also a form of the hydropower which converts the tidal energy conversion systems, or the tidal power plants actually converts the energy of tides into the useful form of power. Mainly it is the electricity. Tides are the waves caused due to the gravitational pull of the moon and sun. These ocean tides are periodic in nature. They are periodic rise and fall of ocean water level, and this phenomena is taking place twice in each lunar day. During one lunar day, the ocean wave level rises twice and fall twice. So, these swings in the ocean water, these waves in the ocean water are actually used to generate electricity, and this system is said to be the tidal power plant or the tidal energy conversion system. The time interval between a consecutive low tide and high tide is 6.207 hours. So, in this manner, as the time interval between the consecutive low tide and high tide is known, so the output of tidal, the output of the nature of power output of tidal power plants can very well be predicted. They are more predictable as compared to, they are very much predictable, I must say, as compared to the wind electricity generation system. Tidal range is the difference between consecutive high tide and the low tide. During high tide, what actually happens is the water flow into the dam, and during low tide, the water flow out, which results in moving the turbine. In fact, the movement of turbine is actually dependent upon what kind of tidal power plant we are having. We may have rotation of the turbine during high tide as well as during low tide if the construction of tidal power plants support the same. Although not yet widely used, the tidal power plant has potential for future electricity generation. Tides are more predictable than wind energy and the solar power, as I mentioned just before this. Let us see the working principle of tidal power plants. The tide or wave is periodic rise and fall of water level of the sea. These tides occur due to the attraction of sea water by the moon. These tides actually contain large amount of potential energy, and this potential energy can be harnessed for generation of electrical power. So, when the water is above the mean sea level, it is called the flood tide, and when the water is below the mean sea level, it is called the ebb tide or the high tide and the low tide respectively. To see the working, to understand the working, let us see the arrangement. The arrangement of the same, the tidal energy conversion system, is shown in the figure. The ocean tides rise and fall, and the water can be stored during the rise period, and this can very well be discharged during the fall period. So, by constructing a dam, we can harness this energy. A dam is constructed separating the tidal basin from the sea, and the difference in water level is obtained between the basin and the sea. You can very well see this is the tidal basin, this is the tidal basin or the sea, this is the tidal basin, this is the sea, this is the high tide, this is the dam. This portion is actually working as the reservoir. Tidal basin is nothing but a reservoir. An opening, a sluice gate is provided over here, and at the sluice gate, a water turbine is installed. That water turbine has a coupled generator for generation of the electricity. So, what happens during the high tide period? During high tide period, water flows from sea into the tidal basin, which can very well be seen. This is the sea, this is the tidal basin. During high tide period, the water flows from sea into the tidal basin through the water turbine. So, as I mentioned earlier, depending upon what type of tidal power plant we are having, we can generate electricity during high tide as well as during low tide. So, the turbine unit operates and generates power as it is directly coupled to the generator. The turbine unit is directly coupled to the generator. Now, what happens during low tide? During low tide period, water flows from tidal basin to the sea, which can very well be seen. This is the tidal basin, this is the sea. The sea level is less than the level of water stored in the dam in the tidal basin. So, during low tide period, water flows from tidal basin to sea. As the water level in the basin is more than that of tide in the sea, so during this period as well, the flowing water rotates the turbine and generates the power as the generator is directly coupled with the turbine. So, the generation of power only stops when the sea level and tidal basin level are equal. In that case, there cannot be any head to cause circulation of water either from the seaside to the tidal basin or from the tidal basin to the seaside. There are many advantages of tidal power plants, although they are not much. As of now, as on date, we don't have much commercial tidal power plants, but the advantages are numerous. It is free from pollution as it does not utilize any kind of fuel. It is superior to hydroelectric power plant as it is totally independent of rain. It is something which is very much important. It improves the possibility of fish farming in the tidal basins and can provide recreation activities for the visitors and holidaymakers too. There are certain disadvantages of tidal power plant as well. Tidal power plants can be developed only if the natural sites are available and it is feasible to construct a tidal power plant over here. Without such natural sites, the tidal power plants, it's difficult to build the tidal power plants. As the sites are available on the bays and the bays are always far away from the load center, the power generated has to be transmitted over long distances. This is definitely going to increase the transmission cost and the transmission loss. Initial investment, additional investment in laying down the transmission system too. So, let us just go through the details of the tidal power plant. They are generation of electricity is dependent upon the tides. The tidal electricity generation works as the tides comes in and again when it goes out. If we are having a bidirectional turbine, we can harness the energy and both cases. We can harness the energy in both cases, that is during the high tide as well as during the low tide. The turbine is driven by the power of the sea waves in both directions. The main parts of tidal power plant. A tidal power plant consists of three main parts. The three main parts are, the first one being the barrage itself, holding the water back during the high tide. The second part is the sluice gate that let water through the third part, and third part is the turbine and the coupled generator. So, a tidal energy conversion system basically consists of these three main parts. Starting with the tidal barrage. A tidal barrage is a dam-like structure and it is actually used to capture the energy from masses of water moving in and out of a bay or river due to the tidal forces. Then comes the sluice gate. The sluice gates on the barrage control the water levels and flow rates to allow the tidal basin to fill on the incoming high tides and to get emptied through the electricity turbine system on the outgoing or low tide. A two-way tidal power system generates electricity from both the incoming as well as the outgoing tides, that is during high tide as well as during the low tide. The sluice gates are left open during the high tide and closed after that during low tide to create a water level differential, creating a potential difference that powers the turbine when water is released. Water is released during the low tide. Tidal stream generators are very similar to wind turbines except they are below the water surface instead of above or the land. The turbine and generator converts the movement of water coming from change in tide, the kinetic energy, into the electrical energy. The water is almost 1000 times or 830 times denser than air, and hence it can generate electricity at low speed of the turbines. Various types of tidal power plant are as follows. We may have single basin arrangement or the double basin arrangement. In single basin arrangement, we can have single basin single effect, single basin double effect, and double basin. In double basin arrangement, we can have double basin paired basin plant and we can have the double basin linked basin plant. Starting with the single basin single effect. This scheme has one barrage and one water storage basin. One-way system, the incoming tide is allowed to fill the basin through sluice gate during the high tide, and impounded water is used to generate electricity by letting this water flow from basin to the sea through the turbines during single basin schemes. Right? The single basin schemes generate intermittent. The power generation out of these schemes is very intermittent in nature. So, in a single basin, single effect turbine, we have a single basin, enclosed basin. This arrangement, sluice gate, also have the turbine installed over here in this area. During high tide, water is filled into this basin, and during low tide, no conversion of energy takes place during the high tide here. During the low tide, what happens is, because of flow of water from the tidal basin to the sea, turbine is allowed to rotate. So, during low tide only, when water is released from the tidal basin, generation of electricity takes place. Then comes the single basin double effect system. In this particular system, we have the reversible turbine. So, the reversible turbine is installed and power is generated during filling as well as during emptying of the basin. So, basin fills in during rising tide and water flows from the sea to the basin and drives the reversible turbine, which generates power with the help of the generator, right? The basin is emptied during the lowering tide or ebb tide. The water flows from basin to the sea and turbine and the reversible turbine generates electricity with the help of generator, which is coupled at the shaft of the turbine. So, in single basin double effect system, to summarize, we have a single basin, but we have a reversible turbine. So, during high tide as well as during low tide, water is allowed to flow through the turbine and generation of power takes place during high tide as well as during low tides. Then comes the double basin scheme. In the double basin scheme, there are two basins on the landward side with the powerhouse located at the interconnecting waterway between the two basins. It is actually there in one system. Double basin arrangements have got two systems: double basin paired basin plant and double basin linked basin plant. In double basin paired basin plant, just go through this, just see this, keep it in mind. It is high basin reservoir, it is low basin reservoir. In double basin tidal power plants, two basins at different levels are made and a dam is provided in between them. So, dam is provided between these two basins. The inlet and outlet sluice gates are made in the dam. So, we have got the inlet or sluice gate for high tide, we have got the outlet or the sluice gate for low tide. The water level in the upper basin is maintained above the level of water in the lower basin, and it is actually the head of water, difference of head in water between these two basins, which is responsible for conversion of that potential energy to ultimately to electrical energy. The single basin is divided between two basins called high basin and low basin. As I told you, these basins are separated by a partition barrage. The main barrage is built between ocean and the two basins. High basin gets periodically filled during every high tide from the ocean water through the sluice gate. H is for high tide. The low basin gets periodically emptied by flow of ocean to the ocean through sluice gate SL during the low tide. The turbine generator is installed in the partition barrage. The partition barrage is somewhere here. The turbine and generator are installed in the partition garage. Water flows from high basin to the low basin through this turbine. This flow is controlled such that continuous power is generated without waiting for these tidal sequences. So, this particular system of tidal energy conversion gives us more constant, almost constant power output. The capacities of two basins should be sufficient large enough to obtain a continuous electrical power output. The other system is double basin linked basin plant. So, double basin linked basin plant, the structure can be seen over here. Two barrages are built between basin and the ocean. In this particular scheme, power is generated during low tide as well as during high tides. What happens during these two tides? During high tide, high basin is filled by sluice gate, and during low tide, the high basin discharges via the turbine, right? During high tide, the low basin is filled via the turbine, and during low tide, the low basin is sluiced via the SL or the another sluice gate. Let me show you the structure again. This is SH sluice gate for high turbine, and here we have got the high tide, and here we have got the sluice gate for the low tide. So, that's all about this lecture. Thank you.